In the previous video lecture, we had discussion on the electrical power in a series combination of resistors. Now in this presentation, we will be talking about the voltage sources in series. Now the voltage sources is connected in series in order to increase or decrease the total voltage to a system. Now we will be understand soon that how we will connect two or more voltage sources in series in order to increase the total voltage to a system or in order to decrease the total voltage to a system. Now to understand this in a more brief way, let's take an example. If we have two batteries available in our laboratory and we need total of 28 volts for our analysis, so how do we connect these two batteries in order to obtain the total of 28 volts? And the first battery is having a 12 volt of potential difference across its terminals, and the second battery is having a 16 volt of potential difference across its terminals. Now basically there are two combinations possible to these two batteries in order to increase or decrease the total potential difference, which are in which the first one is the two sources are connected with the same polarity, and the second one is the two sources are connected with the opposite polarities. So by the same polarities, we mean that if we assume the direction of a current from A towards B, so the current is entering at the negative side and leaving the positive side for E2, and for E1 also the current is entering at the negative side and leaving at the positive side. So we can say that these two sources are connected with the same polarities, and the resulting potential difference across point A and B would be increased. Now for this case, if we assume the direction of the current from A towards B, so the current for E2 is entering at the positive side and leaving at the negative side, but for E1 the current is entering at the negative side and leaving the positive side, so both the sources are connected with opposite polarities. So for this case, the total potential difference across point A and B would be decreased. Now for this case, the total potential difference between point A and B would be equals to E1 plus E2. While for this case, the total potential difference between point A and B would be equals to E1 minus E2. Now here E1 is equals to 12 volts while E2 is equals to 16 volts. So the total potential difference is equals to 28 volts. Now the total potential difference across A and B is 28 volts, which is the desired voltage for our analysis. Now for this case, the total potential difference would be equals to E1 is 16 volts while E2 is 12 volts. So the resulting potential difference is equals to 4 volts. Now we can represent these two sources E1 and E2 by a single voltage source between point A and B, and the polarity of this DC voltage or this equivalent voltage source is the A terminal would be the negative terminal and the B terminal would be the positive, because if you look into this combination, this A terminal is more negative than as compared to B, and this B terminal is more positive than as compared to A. So the polarity of the B terminal would be positive and the A terminal would be negative. So we can take the polarity of this equivalent DC voltage source as the polarity of the larger sum in this series combination of this DC voltage source. So the polarity of the larger sum is the negative terminal is A terminal and the positive terminal is more dominant towards B. So the B terminal would be positive and the A terminal would be negative. Now for this case, we can also take the equivalent potential difference or voltage source of these two voltage sources between point A and B, which is 4 volt. And the polarity of this DC voltage source would be as the polarity of the larger sum in the series combination of this DC voltage source. So the polarity of this 16 volt is the A terminal is more dominant and negative and the B terminal is more positive. So the B terminal is more positive as compared to the A terminal. And now the resulting direction of the current would be from positive terminal towards the negative terminal. So for this case, the direction of the current would be from B towards A, because the current here is also leaving because the direction of this DC voltage source is from positive, and of this DC voltage source is also from positive towards the negative. So the resulting direction of these two DC voltage sources is from B towards A. So we can take the direction of these two DC voltage sources is from positive towards negative. And for this case, the direction of current is also from B towards A, because the voltage rating of E1 is greater than the voltage rating of E2. So the direction of the current will also be the direction of this E1. So the direction of the current will be from B towards A. Now, what are the main factors which will be affected if we connect voltage sources in series? So the following are the factors which affected or unaffected when we connect the voltage sources in series. The resulting terminal voltage will be increased or decreased, which we already discussed that if we connect voltage sources in series, the resulting voltage will be increased or decreased. The second point states that the current will remain unaffected. So as we already discussed in the video lecture of a series combination of resistors, that for any series combination the current would be the same through each point in the circuit. So this current I, let's say, would be the same through each point in this circuit. The total electric power will be increased or decreased according with the voltage level. So as we know that the power is equals to I into V. I is remain unaffected for the series combination, and the voltage is affected in the series combination of the voltage sources. So if the voltage is increased, the total power would be increased. Now if the voltage is decreased, the total power would be decreased. So it's all for today's presentation. If you have any doubt, ask in the comment section. In the next video lecture, we will be talking about the voltage divider rule. So see you in the next one.